those two factors create a situation that has a product of 0. In order for two factors to create a product of 0, what must one of these factors equal? 0. All right. Which means the following. If I solve both of these for 0, I get the following. Okay? X minus 2, or x is negative 2, or x is negative 5. X is positive 5. Now, let's test that to be sure. I'm going to plug in the 2. Negative 2 plus 2 multiplied by 2 minus 5. Thank you, Connor. 0 times negative 3. Does that equal 0? True. This one is true. How about over here? Let's test this one. We'll test that one. 5 plus 2, 5 minus 5. 7 times 0. Does that equal 0? Yes. Which means that either of these situations would produce a true answer. Okay? So your answer to this is going to be negative 2 and 5. Negative 2 or 5, I should say. Okay? I might give you another example. This is the same kind of problem. X minus 3, x plus 4 equals 0. In order for this to be true, one of those has to be a 0. So I'm going to solve both pieces for 0, just like I did above. If x minus 3 is 0, then x has to be 3. If x plus 4 is 0, then x has to be negative 4. Do you guys see how I shorthanded it? I subtracted, I added 3 to both sides. I subtracted 4 from both sides. If we test these to see if they're true, first by plugging in the 3. So 3 minus 3 times 3 plus 4, 0 times 7. Does that equal 0? Yes, it does. Or we can test the other one. Plug in the negative 4. Negative 4 minus 3, negative 4 plus 4, negative 7 times 0. Does that equal 0? It does. So what you're learning here is if you have a polynomial that's already factored into 2 chunks, or 3 chunks, 3 factors, you solve for any possibility that would create a 0 in the product. If you plug in a 3, as you can see, we create a 0 for the product. If we plug in a negative 4, as you can see, we create a 0. The answer for this one is going to be 3, negative 4. They're not always going to be that clean, though. Example 2, we're going to move on. Example 2 has 3 factors. Look at example 2, 5n, and minus 3, and minus 4 equals 0. Do you guys see that? I now have 3 factors. In order for 3 factors multiplied together to equal 0, at least one of the factors must be a 0. So instead of solving 2, you're going to solve all 3. 5n equals 0. Divide by 5. 0 divided by 5 is 0. N minus 3 is 0. Add 3. N is 3. Last one. N minus 4 is 0. Add 4. N is 4. Okay, that's what I believe my solution set to be, but I'm going to solve by plugging in each scenario. I'm going to verify it by plugging in each scenario to make sure I'm right. Now I'm just showing this to you so that you understand why it works. I'm not requiring you to check every single one because, well, let me back up. Because I've already factored it, so I already know that if I multiply something by 0, or if I multiply something by another thing that creates a 0, that I'm right. So the first one, 5 times 0 multiplied by 0 minus 3 multiplied by 0 minus 4 equals 0. So this one created a 0. 0 times negative 3 times negative 4. Does that equal 0? Then the first solution is true. Let's try a 3. 5 times 3 multiplied by 3 minus 3 multiplied by 3 minus 4 equals 0. 15 times 0 times negative 1. Is that true? Absolutely. Last one, if I have a 4, 5 times 4 multiplied by 4 minus 3 multiplied by 4 minus 4, plugged in my value where the n's were, 20 times 1 times 0. Does that equal 0? Which means my solution set of 0, 3, and 4 is true. These are nice and easy. They're already factored for you. But what if I just give you a quadratic equation? What's a quadratic equation, Mrs. Myers? Look at the top of page 231. Polynomials are numbers and letters combined to create something, whether it's a sum or a difference, okay, a product. If I have 6x plus 1 equals something, that's a linear equation. That's the first type. 6x plus 1 equals 12. That's linear. If I have 3x squared plus 12x plus 4 equals something, that is called a quadratic. Okay? Quadratic, meaning the highest degree is a perfect square, a square. The third type is cubic. 3x squared cubed plus 2x squared plus 4x plus 1 equals something. The highest degree was a 3, therefore it's cubic. What we are learning about today is how to break those down into factored items equaling 0 so that I can solve for possibilities that will make this true. Example 3. 2x squared plus 5x equals 12. How am I going to solve for this? First, zero it out, which they call convert it to standard form. I want to create one side to be a 0. The easiest one for me would be to subtract 12. So now I have 2x squared plus 5x minus 12 equals 0. Okay, it's starting to look like what you've seen before, but it's still not factored. It's not a perfect square. It's not a difference of squares. Factors of negative 24, whose sum is a 5, 1 and 12, 2 and 6, 2 and 6, 24. 1 and 12, no, 2 and 1 and 24, 2 and 12, 3 and 8, 3 and 8. Will 3 and 8 work? Absolutely. Let's break it up and work with my 3 and my 8. I'm going to put my 3 here and my 8 here. In order to create a negative with a positive 5, this one has to be positive, this one has to be negative. This is what we've been learning about. We're factoring. Pull out my 2x, x plus 4, negative 3. Oh look, x plus 4. Group, group. And you're going to have 2x minus 3 and x plus 4 equals 0. Okay? Equals 0. Next step, solve for 0, which is what you've already done up here. Okay, this is where you've started examples 1 and 2. Example 3, you had to get there by zeroing it out. I moved the 12 over, so 0 was on the right, the negative 12 lived on the left. I factored, giving me this, and now I have to solve. 2x minus 3 is 0. X plus 4 is 0. Either of those scenarios has to be true in order to create a 0. If I add 3 and divide by 2, plus 3, 2x is 3. Divide by 2, x is 3 halves. Okay, I'm shorthanding this for time. Okay, divide both pieces by the coefficient, you end up with 3 halves. Add 4, and x is 4. Okay, you guys see that? They've checked it for you to show you what that looks like. Again, we've already done that. They checked it by plugging it back into the original equation. That is the most effective way to verify that you're right, and it's kind of fun. If you plug it in here, you should be okay as well. So, negative 4. Your solution set is 3 halves and negative 4. They checked it for you. They showed you it was right. Example 4 is the exact same thing, only instead of being a quadratic, which has a highest degree of a square, it's a cube. Highest degree is a cube. 18y cubed plus 8y plus 24y squared is 0. Notice they've already zeroed it out by moving. So if I had it like this, 18y squared plus 24y equals negative 8y, you would add your 8y over and zero it out. Do you see what I'm saying? They've already shown it in this format.
Michaela, do you want us to be office, please?
Let's factor. 2. I think 2 is all I can pull out. And y. 2y. 9y squared. And I'm going to put this y at the end. Plus 4 plus 12y. I rearranged it so that I could see if I have a difference of squares. I put this one here after I factored it out. I put this one here after I factor it out. And you can do that. Remember, factors can be arranged according to your needs. Is this a perfect square? Square root is? Is this a perfect square? Square root is? If I multiply 3y by 2 and double it, can I get a 12y? What must this sign be? So the factor is 2y times 3y plus 2 times 3y plus 2. Okay? So you're going to solve each piece for 0. Now since this is squared, notice this and this are listed twice. Do I really need to list it twice? I'm going to come up with the same solution, aren't I? Alright, let me show you what I mean. Divide by 2. This has to be a 0. Over here, subtract 2. 3y is negative 2. Divide by 3. Y is negative 2/3. What do you want to bet? I'm going to come up with the same thing here. Subtract 2. Divide by 3. So I have 0, negative 2/3, and negative 2/3. Do I really need to list that negative 2/3 twice? No, because if I plug it in and test it, I'm not going to test it twice. So 0 works and negative 2/3 works. They show you the check there for you. Okay? Incidentally, because this appears twice, it is called a double root. Okay? Because it appears twice, it's called a double root. They give that in the paragraph below. And they also tell you, though, list it only once in the solution set. Don't waste your time. All right? Don't waste your time on it. Okay. You're doing odds today. I expect to see all your